Speaker in this room. Yeah, is the speaker here yet?
Hello.
Oh, okay.
Yep, I'm here.
So we will start soon.
Yes, I'm ready. So let's check about my mic. Do you hear me clearly?
Yes. Well, I
Yes.
hear you clearly. So before we start today's session, I would like to say a few words for the audience. Please, again, mute yourself during this session in order to ensure for a smooth running events. And for the speakers, please turn on your camera for a better connection with the audience.
Okay.
Yeah.
Did you see me now?
Yes, Bob.
So okay.
Thank you. So we may start now. Good morning, ladies and gentlemen. My name is Srey, and I'm a freshman from Civil Engineering Department and your MC for IT Day. It is my pleasure to welcome all of you here this morning. I hope you enjoyed the last session, and we would like to thank you all for making time to join us today in today's event. So for this session, I would like to invite our speaker, Mr. Sambath Srey. Is that right, Bob?
Yes,
Yeah.
that's right.
Okay, who is our senior from CS department to present about Gestspeech, sign language gesture recognition, which is another great topic about how to build a web-based application that can recognize basic hand gesture as well as convert and generate hand gesture to speech according to hand gesture input. Yep. So if you have any question during this session, please feel free to write them down in the chat box or wait until the Q&A comes to turn on your microphone and ask the presenter yourself directly. So without further ado, I would like to pass the mic to our speakers and good luck. The stage is yours.
So good morning, everyone. So today it's my honor that have to present you about my project, which is my final year project on the computer science department, and I have an opportunity to present these projects on the IT Day as well. So the title of the project is Gestspeech, which is the gesture to speech we're using MediaPipe. So first of all, I would like to express my gratitude and thankfulness to the two people that have involved and during my project journey. So the first one is Mr. Rajiv Hikimo, which is who is my supervisor. And second one is Dr. Ambrody, who is my project coordinator. So um, I come this far to finish these projects because of them and really thank for them to help me during my journey. And let me introduce myself. Hello again, I am Sambath Srey, and currently I am a software developer and I love to talk about tech. Yes. And so next, here are the table of contents that I am going to cover today, which include the introduction, followed by the problem statement and motivations, and followed by the technologies implementation, and as well as the finally we go to the demo of the application that we have built. Yep. So introduction. I would like to stress out about the hand gesture. So hand gesture is basically design that is made from hands and fingers to form a meaning, and we use that to communicate important messages. So for example, like you do this, which means like, and you do this, which means does not like, right? And hand gestures simplify human daily life. People can control devices like smart home or control things virtually without physically touching them, which means the real example as in the smart home. People actually can use their hand to wing in front of the TV or in front of air conditioner to turn off to switch on the switch to or to switch off just by doing that because they have of the sensors of the electronic device. And these kind of activities is related to um, gesture recognition. Yeah. So I have seen these kind of technologies and these kind of activities that available right now, and I pop up with an idea. Why don't we use those kind of hand gestures to make a muted person speakable? So here are the solution. Gestspeech. Welcome to Gestspeech. Gestspeech is a web-based application aimed to help muted people, uh, muted people to speak to everyone. So let's move on to problem statement and motivation. Why I have the what problem that I have seen, and what is the motivation that lead me to initiate these projects to implement this application. So the reason is that I have seen that misunderstand about the conversation. A muted person use the sign language, but normal people does not. So imagine that there is a muted person. They try they come to you and try to speak to you, and they try to ask the sign language, and you don't know the sign language, and imagine how disgusting it is. I think you may have this kind of experience, and you also can see these kind of activities that they try to make it for fun in the TV show as well. Like the games, there are two people, they are partner, and one partner is reading on the paper, which is the activity that they will act, and another partner will try to look on the activity, and they will try to guess what it is. And the result, when it is wrong, it leads to fun, right? So the purpose of the game is to make fun, and it's supposed to have another partner who try to guess will misunderstand what they are doing, and that's the problem of gesture, or the problem of sign language. The people who does not know about sign language, they won't understand, and it must be have a misunderstanding about the conversation, and it will, if in the real situation, it will lead to cause any problem because of like, for example, like the muted person wants another person to do something, and will misunderstand and will do something wrong to them in a different way, something like that. And that's the problem that I have seen. So so now, for example, I just want everyone to see what I am speaking. And if you understand what I'm talking, you can write down on the chat. Yeah. So did you see me clearly right now? Yeah, I will speak the sign language for you. Yes. So again, yes. Yeah. I guess everybody would not understand about it. Yeah, but let's try to put down your message on the message, but on the chat. So let's move on. So after I got the problem, I seen the problems. So I have to solve the problems. So the objective of the project is, no, not yet. Sorry. So before that, I have to state my objective of the projects. So I have to stress out to focus on the differences between sign language and gesture. So sign language is a system of hand and body movements, facial expression. So in this term of the system of hands and body, which means the hands and the body has the relationship, the system and hand and the body movement, and also includes the movement of the hands movement, and also the facial expression. Sometimes the facial expression also relates with the sign language as well. And like, for example, you have this kind of gesture, which is a point finger. When you point in different parts of the body, it will change the meaning. For example, when you point on the mouth, the meaning is the mouth. When you point on the nose, the meaning is the nose. While gesture is a static sign performed by the hands fingers. So it's just a static sign. For example, like you do this, which means like when the hands, the position of the hands move to wherever, it still means like, even though it's moves, even though it's their position is anywhere, it still be the same meaning, which is the gesture. So now you understand about the term of the difference of the sign language and gesture. So why the reason that I have mentioned about these two terms? Because of the limitation and the scope of the projects. Because of the design language contains a lot of more complexity of the system and movement and facial expression. So I would like to narrow down the scope of the projects. which is to only recognize only the gesture, while to make sure that the projects have also have the right track or the right path or the right direction to go through to the sign language implementation. Which means when I finish these projects, people or in the future I can expand more, um, expand or scale up the projects in order it to work with the sign language. So here are the objective of my project. Is an application that can convert user gestures into speech, which is not sign language. So technologies. So during the project implementation, before I implement, so I have to do a literature review, and I have found the available technologies that I have that I can use to implement my projects. So the first technology is a webcam or camera. So for the webcam or camera, which is, as you know, it's record your picture or or video. So as long as the computer has the frame of a picture or a frame of videos, they can take those data to analyze, to making analysis on the picture or on videos. So in this term of analyzing, which means you can relate to machine learning. So in case of everybody does not know about the term of machine learning is the study of computer algorithms that improves automatically by experience. So for example, you have a tons of data, which is a training data sets to give to machine learning, and machine learning train those data, and it will create a model, which is the rules. The model is the rules that can that, that take another input. So the rules will analyze that image is something in terms of your training. So the second technology is sensor glows. So as you can see in the image, there is a hand or a person hand that they're wearing gloves, and there's sensors attached all the 5 fingers. So whenever your hands or whenever the hands or the fingers moves, the sensors will move as well, right? So that sensors is the function of that sensors is specifically to detect the movement, to detect to detect the bench, the position between each fingers. So the computer got the signals or got the data, and they can use those kind of data to make analyzing as well, to make prediction or to make prediction what gesture is this the people are trying to act. That's for example. So for the second technology, one is lip motion controller. So lip motion controller is a tools that provide the that functions work with the an extra function, which is the depth function, which means the hands between they can estimate the like estimate the depth, the distance between your hand to the tools. So the tools can capture the hands as the 3D dimension. So why do I mention all of these three technologies? Because these three technologies can people they during my literature review I have doing research. The people they tried all the methods, and I have to study about these as well. So I have to make comparison between each technology. So I have to choose one for my projects. So let's talk about the second one, sensor glow. As I have mentioned, I have to make sure that my projects would lead from gesture recognition into the sign language one, right? So I have mentioned already, sign language is related to the body movement, related to the facial recognition, related to the position of the hands, to the face, to the body, to anything. So as you can see in the image, the sensor also only attached with the hand only. So how can the sensors know where the position of the hands to the body? It cannot, right? Because there is no sensor attached on the body. So that technology is crossed out. We don't use that kind of technology. I wouldn't say that this technology could not implement the gesture recognition. Yeah, it could, but like I said, I want to scale it up to the sign language one. Yeah, so that's not would not work with my plan. And as well as like lip motion controller, it's only detects on the hand only. So it have the same scenario of the sensor glow as well. So the remaining technology, which is only webcam or camera, which is the input as in image, like the camera can capture all your body, the face, the hands, and the body, anything of your parts of the body. So it would fit the best one with the webcam camera. So next, so what we can do with the data, like the image. So for the first one is image classification. Like you can see on the image, you have three images of the elephant and three images of a giraffe. So we take these as the training data sets for the machine learning. So the learning model training, and it's produce classifier. Sorry, which is a machine learning model. So that model can classify the image. And another technology is about the object detection. So the term of object detection is quite similar to image classification, but it's an extra one is it has the object localization. As you can see in the image, there are two objects inside the image. There is a dog and the cat. So the first of all, it needs to localize. It needs to predict that there are two objects inside the image, but it does not know what is that object. It does not know about dog or cat. So it's only localized where is the objects, and then it uses the image classification to predict that that object is a dog or that object is a cat. So it's quite similar, but the terms of the object detection, it would work with the objects. I wouldn't say that it would not detect the sign language, but as you can see, the sign language is only involved with the hands. So, for example, like the hand gesture is involved in 100, gesture, and sometimes the each gesture quite similar, very similar to each other. And the object detection, the purpose and the algorithm of the object detection, it will classify the different objects. But when you use the same hands, but the difference only the fingers and quite similar. So the object detection model would not work. The accuracy would not work very well with this kind of scenario. So the only choice that we have used is to use the hand landmark model, which is provided by the MediaPipe. As you can see here, the image here, which inside the image is who is me. Uh, I use the hand landmark model to detect the 21 landmarks on the hands, and also we use the pose to detect that the position of the hands, the position of the body, and also we use the face mask library to detect the face as well. And as you can see here, we have the hand, we have the pose, the body, and we have also the face. Like I have mentioned before, sign language contains all of these terms, factors, hands, body, and face. So it worked the best with this scenario. So let's move on to the technology that I will use, the main technology that I will use to implement the projects. So first, Next.js, which is a React framework, which is a React framework. It's completely the same React as a front end development. And for the MediaPipe, I use MediaPipe for the because MediaPipe provide the library for the hand landmark detection model, and also face mask and postnet as well. For the digital hosting is the cloud server that I use to host my application online to live for everybody to use my application. So on the demo, you will see my application. So let's move on to implementations. What's the process and what I have done on my implementation process? So first, I would like to explain you about the hand landmarks. As you can see on the image, our hands contains 21 points from 0, which is the root, and each finger has 4 points. So one finger has 4 points. So 4 points for, no, sorry, five fingers, right? 5, 4, so it's 20 plus the root point, so it's 21. And the 4 points of each finger, it contains its name, which the top is the top we call a tip, and the downward one is we call dip, and then we call another point is pip, and then when this row is MCP. Yep. So the name is only varies into it varies only the prefix of the each finger, like pinky, middle, or ring, or something like that. And yes, that's the main concepts of the landmarks of the hand landmarks. So here are the results of the detection that of the hand landmark detection model that provided by media pipes. So whenever the camera detects our hands, it will detect the 21 points. So here are the result, the data that we got from 0 as an array from 0 to 20. And each point contains the coordinate x and y, the coordinate of the points. And for the z one is the depth, as you can as you already know that you also your hands is in the like the 3D dimension, right? So we have the term z, but the z is not the coordinate, but it's the depth. Like for example, right now your hand is straight like this, so the depth, it's compare the depth between the each point to the roots, to the roots. So when like this, it might be 0, but when it's the scope is like this, it would be positive, and when like this, it would be a negative one. So the range of the z is from -1 to 1. And MediaPipe also Hellenmark MediaPipe model also support multi hands, like 2 hands. So on the second optics multi-handness. So now the detection only 1 hand. Its label is right. So the detection of the hand is right hand. Whenever you get into the frame 2 hands, the multi-nest array would be changed to 2, and it will be the label left, and another object, another index will be right, left and right. So let's move on to finger status. So after we got the data from the hand landmark detection, we got only coordinate of the each point of the hands, right? But we have no idea about how. What gesture is that? What gesture is this? What gesture of this gesture? So I have to define my own way, my own definition of finger status. As you can see in the image, I have divided 3 status of each finger. So the fingers has the fold state, curve state, and straight state. So for the fold state, whenever the distance between the tip to the root is less than the distance from the MCP to the root, as you can see in the image here. D1 is the distance from the tip to the root, and the D2 the distance between the MCP to the root. So like here, whenever like this in the state, it would not, the distance from the tip would not greater than the distance from the MCP to here. So it would not be in the in the fold, right? Whenever it's come here, the distance is lesser than. So it's become the the fold state, the fold status. So the second one is curve status. So the curve status can be calculated by the angle of the dip, and the pip is between 110 degree and 170 degree. As you can see here in the image, like the angle 1 and angle 2, whenever those two angles are between 110 and 170 degree, it's on the curve state. Like here, whenever it's vary on between 100 and 170. Yeah. And finally, the straight status. So we have only defined the three status. So whenever it's out of the fold and out of the curve, it would be in the straight status. So next, we talk about the formula and the method that we use to calculate the distance between the 2 points, like here for the distance to calculate on the fold status. So we use this kind of formula d equal to x2 minus x1 square plus y2 minus y1 square, and in overall is square root. So where the d is the distance between 2 points, and x1, y1, x2, y2 are the coordinates of each point. That where we got the x1, y1, and x2, y2 from here. Here, like the result that we got the detection. After we got the distance, and then we compare the after we got the distance, and then we compare the distance. And if it's in the logic that we have coding, it will be in the fold status. Yeah. And here is the I'm sorry for the title of here. It should be the angle between two lines. So here are the formula that we use to calculate the angle. Theta equal to arcos. Here is the vector x dot vector y is divided by the norm of x, the norm of y, where the theta is the angle of the two lines, and x is the vector of the first line, y is the vector of the second line. Sorry, there's a lot of mistake on the slide. Y is the vector of the second line. So the top of the vector, you can check out more on the internet or math class. And suppose everybody knows about the vector. Yeah, it requires 2 points from here to here, and it uses the formula to calculate the vector. Yep. So after we got the status, fold status, curve status, and straight status, we have to define the gesture definition. Like for example, as you can see in the image, is the light gesture. So the status of the thumb finger is straight, right? And the status of the fold finger of the index finger, middle finger, and ring finger, and pinky finger all as in fold status. So I have defined index finger fold, middle finger fold, ring finger fold, pinky finger fold, and thumb straight, right? Thumb straight, but the direction of the thumb is straight up. Whenever the direction of the thumb is downward, it would be the dislike. It would be the different meaning of the gestures. So after we got the after we define the definition of the gesture, we got the result, right? And then what do we do with the results? We have to display the result on the interface for the user, and as well as the most importantly is about the speech. We have to generate the speech because the purpose of the application is to be a mouth, to be a is a to be a mouth for the muted person, because muted person only use the gesture and it will speak for them. So in order to generate speech, I have two ways. First, I have to use a library, which is the text to speech library, which I have to give only the text, and it will read the text automatically by the machine. But for this way, it supports only the English language. So for the command language, it does not provide with those kind of libraries. So I have the another way to do the speech manually by recording my own voice or my own speech, and I play the clip, the correspond clip whenever the gesture is being acted. So I use the online voice recorder here, as you can see on the image, to record my speech and save it locally and use on my projects. So that's it, the process of what I have done. So let's move up let's move up to the demo part, and we will and I will state some more future work of my project as well. So here is the link for application. Everybody can go and test out. I will paste it on the chat as well. You can try it. Yeah, wait a little bit for loading. It will load the model. So as you can see here, there is no hands inside the frame, so it will not detect anything. But sometimes you can see it's because of the model detection, it has some low accuracy of it, so it will detect even there is no hand. You can see, but it's not ghost. Honestly, it's not ghost. Sorry about it. So I will move the frame to make a different angle. Yeah, so it worked now. Here, it is my hand is 5, right? So before that, I have to mention about the let's move out to another navigation first. So here we go to learning gesture sessions. So I divide I divide it into two parts, which is gesture and number. As you can see here, the gesture of victory, it would do like this, and the number two, it would do the same. So some gestures have the same gestures but a different meaning. So I have to divide it into a different category. So yeah. So now we have a number and gesture, and here is just the page that gonna talk about myself, and here is the feedback form that everybody could when you try my application, and I want you to also fill in the form for me as well to do a survey to get some feedbacks. Yeah. So let's move on to the application, the main application. Let's try it together. So here, like I mentioned, we have number and gesture. Whenever you want to detect gesture, you click on gesture. When you want to detect number, you click on the number. And our application also support two language, which is Khmer and English as well. So now first we would do with Khmer, and here is detect the number. So here is the one. So here you can see here the because of the presentation, it would not record the sound system, so you would not see the you would not hear the sound. So you can test it on your real device, it would work with the sound. Yeah. So let's see here, one. So here is two, three. It's also work with the two hand. So when my right hand with raise up with the 5, it would be 8, right? Yeah, it would be 8. And here it's 7, and it works this way too. When you do this 5, it's 10. You see, it's 7, and here it's 7 as well. Yeah, it works that way as well. And you can change the language to English. Yeah. And that's it for my application. And I think it's, even though it works with the only gesture, but when in the future I would scale it up to work with the sign language and implement more to calculate the relationship between the hand landmarks with with the hand with the body pose and also with the face mask, like I have shown you in the image here. It works with this kind of detection. And that's it for my presentation. So if there are any questions, you can raise up.
Oh, wow, that's a very great presentation from our speaker, Mr. Sambath. Right? Thank you so much for presentation. And I try your app. It's worked really well, very impressive. I did not expect it to be very well like that. Like,
Yeah, thank you.
yeah. And I hope to see this kind of technology implement into our country as well. Yeah, very soon. Yeah. So right now, if you have any question, please kindly ask in the chat box, or you can ask them directly. Ask him directly by turning on your microphone. So if you have any question. So but if you don't have any question, I would like to ask myself.
Yeah.
So uh, so what are the challenges that you have faced during this project?
So the challenges is during the literature review. So first of all, I don't know how to um wait, sorry. I would present again. I will show you the slide here on the available technology that being used. Like people try to use sensor glows, people use lip motion, and people use a camera to detect like image like that. So as the terms of the gesture recognition, because of the word gesture recognition, so I go into different paths. So the first step of the project, I walk in different in the wrong way. I use object detection here. I use this technology to implement the project. So, like I have mentioned, the object detection algorithms it won't work in this kind of scenario because it's only detects the different objects. But in terms of the sign language, it's only the same language. It's the same objects, which is hand. It's the same objects, but the objects only varies. Only the difference is the fingers, right? So the detection, the accuracy of the object detection model, it worked very bad, and I have spent a lot of time on this implementation stack. So it was very bad for me. Then so I think so before you try to decide that what kind of technology that you're going to implement, so you have to make sure it works for you. So if you want have make the like the mistake like me, yeah, that's yeah, that's it.
So next, I think next question for me is since there's no one asking. So do you can you see that can you see that in the future will people use this for any kind of purpose at all, like in the future, or just
Um,
maybe yeah.
the question is do I think that in the future people will use my application? So it's not depend on people. It depends on me how good my application is. But I think the demand what if my application work well and the accuracies of the hand of the sign language translation, like for example, like you speak a phrase or a sentence and the accuracy of the sentence would not uh, different, like the detection would not say the difference as like the user trying to say, and the accuracy is good. I think people will use it. Yeah,
Uh,
as long as it does not make confusion.
oh,
Yeah.
okay. Yeah. Thank you for your great answer and explanation to your presentation. So for any last so on this last minute, if you have any question, please ask now before I close the session. So yeah. So if you don't have any more question, we have come to the end of the session. So
Yeah, thank you.
yeah, and thank you to our amazing speaker with great demonstration on your application. And on the behalf of ICT faculty, thank you all for making time to join us here this morning. I'm apologizing for any issues that happened during the sessions. And please don't go anywhere. Please stay tuned. There would be another session happening soon with many more great project presentation. and from other courses with amazing topics such as e-commerce platform, my script spell checking and phrase recognition, and many more from our favorite speakers. So please go and check out our other agenda on our IT Day website. Thank you, and I will see you soon in the next session with another talented MC, so Eng Liang. So have a nice day and goodbye.
Yeah, goodbye. Have a nice day, everyone. Thanks.